In March of this year in Buga, Colombia, something extraordinary happened. A sphere UFO was captured.
A strange metal sphere in Colombia just pulsed for the second time. And what scientists found inside is beyond belief. Hidden layers of unknown metals, tiny inner spheres, and a signal that bends the rules of physics are forcing experts to rethink everything they know about gravity and energy. Is it a probe, a power source, or something even more dangerous? The mystery is deepening, and the truth could change our future. Let's discover. The second pulse, breaking the mystery wide open. The sphere pulsed again. Not once, but twice. The first emission could have been dismissed as an odd mechanical hiccup or a meaningless burst of static, but the second changed everything. A single event might be a fluke of nature or an accident of environment, yet repetition is the hallmark of intention. That's why the scientific community is suddenly asking questions it has never dared to take seriously. Is this sphere trying to communicate? Is it performing some kind of function we don't yet understand? Or is it something far more dangerous? The second pulse was detected in early September during a routine monitoring session at the University of Valle's physics lab in Cali, Colombia, just a short distance from Buga, where the metallic orb was first discovered. The sphere had been placed in a shielded chamber to block out interference from radio towers and cell networks. Researchers connected it to highly sensitive frequency analyzers capable of detecting even the faintest electromagnetic emissions. For weeks, the sphere sat quietly, registering nothing beyond the low hum of background noise. Then, in the dead of night, the sensors recorded a burst of structured energy. Unlike the first time, which many skeptics suggested was equipment error or external interference, this signal was measured across multiple instruments simultaneously, each confirming the exact same pattern. Why does this matter so much? In communication theory, one of the simplest ways scientists distinguish between noise and signal is through repetition. A single unexplained burst could be cosmic static, electrical interference, or even a reflection from a nearby satellite. But when the same structure appears more than once, the likelihood of randomness drops dramatically. Imagine flipping a coin. One head means nothing, two heads in a row might still be chance, but if you keep flipping heads again and again, eventually you stop calling it coincidence. The same logic applies here. The sphere has emitted not one, but two signals with similar timing and internal rhythm. That is no longer random noise, that looks like a deliberate pulse. To grasp why this has shaken researchers so profoundly, it helps to compare the Buga sphere's emissions with some of the most famous anomalies in astrophysics. Take pulsars, for instance, rapidly rotating neutron stars discovered in the 1960s. They emit perfectly timed radio pulses, so regular that astronomers once wondered if they might be messages from another civilization. Eventually, we understood they were the product of extreme magnetic fields and stellar rotation, not communication. Then there are fast radio bursts, or FRBS, mysterious millisecond-long signals detected from deep space. Some repeat, some don't, but none carry internal structures that suggest coded information. The WOW signal, recorded by an Ohio State University telescope in 1977, remains one of the most tantalizing one-off events, an unusually strong, narrow-band radio signal from space. But crucially, it never repeated, and no one ever found meaning in its shape. In all of these cases, the key limitation was repetition or lack thereof. The Buga sphere breaks that pattern because it has pulsed twice, and the internal measurements of the second event suggest deliberate structuring, not just raw energy release. According to preliminary lab reports, the pulse was not a single frequency spike, but rather a series of closely spaced intervals across the electromagnetic spectrum. Think of it less like one loud clap and more like a sequence of beats forming a rhythm. Researchers noted motifs, specific repeating sub-patterns that looked suspiciously like encoding. Some intervals stretched out longer, some shorter, and when plotted visually, the graph resembled a staircase with consistent rises and falls. One scientist described it as a sequence that carries information density far beyond anything we'd expect from a random discharge. Instruments captured frequencies ranging from a few kilohertz up into the megahertz range, which rules out ordinary interference from household electronics. This is where the discussion becomes less about raw data and more about interpretation. If you were designing a machine meant to test itself periodically, you might program it to emit a diagnostic pulse, a kind of self-check system to confirm its components are working. The Buga sphere could be doing something similar. Alternatively, the emissions could serve as a beacon, designed to broadcast its presence to whoever, or whatever, knows how to listen. Others speculate it might not be communication at all, but rather the byproduct of some internal energy mechanism bleeding into our senses, the way a car engine produces heat and sound whether you want it to or not. The implications are staggering. If the pulse carries a message, then we are standing at the edge of humanity's first direct contact with non-human intelligence, even if only through an artifact. If it's a self-check, then the sphere may be a machine that is still operational, raising questions about its origin, its purpose, and whether more of them exist. If it's a beacon, then the second emission may not have been directed at us at all, but at someone, or something, else entirely. And if it's simply energy leakage, then it still represents a level of engineering beyond our current capacity to explain. For now, the information we have paints a picture that is as shocking as it is incomplete. A sphere of unknown origin has pulsed twice, and both times it has emitted something that looks eerily like a structured signal. So, if this is communication, who or what is speaking, and are we the intended recipients? Looking inside. Anatomy of the sphere. The Buga sphere was first discovered in a patch of dense scrubland just outside the Colombian city of Buga after a farmer reported seeing a strange metallic glint in the afternoon sun. Local authorities were called in, expecting perhaps a piece of industrial scrap or a weather balloon fragment, but what they found left even experienced engineers unsettled. The object was completely intact, not dented or scorched, and showed no signs of the kind of impact damage that falling space debris usually carries. It rested on the ground, as if carefully placed there, cool to the touch, despite having sat in open sunlight for hours. How does an object of unknown origin arrive so gently that it leaves no crater, no burn marks, and no trail of descent? Early measurements revealed that the sphere is roughly the size of a regulation baseball, but considerably heavier, weighing just over 3 kilograms. Its surface is flawless, smooth to the point of feeling unnatural, with no scratches, welds, or seams visible even under a microscope. Under certain lighting conditions, faint geometric markings seem to shimmer across its metallic skin, but when scientists attempted to photograph them, the patterns refused to appear consistently, leading some to wonder whether the symbols are optical illusions caused by the alloy itself or some type of adaptive coating. Imagine holding a perfectly polished silver orb that seems to shift when you look at it, as if the metal is playing a quiet visual trick. The first major scientific breakthrough came when imaging scans revealed that the object is not solid, but layered. Using high-resolution X-ray tomography, researchers observed at least 3 concentric shells of differing density inside the outer casing. Each layer displayed a slightly different metallic composition, and between them were tiny spherical structures suspended in an almost lattice-like arrangement. Reports vary on the number of these inner spheres, but most agree there are several, each no larger than a marble, arranged with a precision that suggests deliberate design. Fiber optic-like filaments appear to connect the spheres to a dense core at the center. Some scientists have speculated that this core may house a chip or data storage component, though no one has yet dared to cut into it to confirm. Here's a question that has driven much of the debate. If this is an artificial object, why does it look as though it was grown rather than built? The absence of welds or fasteners suggests a manufacturing process far beyond conventional metallurgy. One engineer compared it to a metallic onion, with each layer nested perfectly within the next, while another likened it to a baseball filled with microchips, its complexity hidden beneath a deceptively simple surface. This is not how human technology is usually assembled, where even our most advanced devices betray seams, screws, or bonding lines under microscopic inspection. Material analysis has only deepened the mystery. Preliminary spectrometry shows a high concentration of titanium and nickel, but with isotopic ratios that deviate slightly from naturally occurring terrestrial samples. These differences are small but measurable, raising questions about whether the alloy could have been produced in a non-Earth environment or through a process not yet used on our planet. Energy tests detected a faint but consistent electromagnetic field around the sphere, not strong enough to be dangerous, but significant enough to rule out ordinary static charge. Attempts to open the sphere using controlled laser cutting were abandoned after sensors recorded a sudden spike in internal temperature, as though the object were actively resisting intrusion. To eliminate the possibility of a hoax, researchers conducted a series of control experiments. Multiple laboratories repeated the scans using different equipment to check for operator error or instrument artifacts. Chemical swabs were taken to detect modern industrial lubricants or coatings that would indicate recent fabrication. All tests returned negative. There were no signs of paint, adhesive, or machining residue. The sphere's surface chemistry matched nothing in local manufacturing databases, and no regional company reported missing or experimental equipment of this type. Still, skepticism remains strong. Some metallurgists argue that the isotopic anomalies could result from natural smelting processes or contamination during testing. Others have suggested that the object might be an elaborate art installation, pointing to the precision of high-end metal sculptures and the rise of interactive art projects that incorporate subtle electromagnetic features. A few even propose that it could be industrial debris from an aerospace prototype, perhaps a component of a satellite or high-altitude drone that fell intact. But if it were debris, why are there no serial numbers, no tool marks, and no records of a missing part? Comparisons to other enigmatic spheres only heighten the intrigue. In 1974, a family in Florida discovered what became known as the Betz sphere, a metallic ball that rolled unpredictably and emitted faint sounds when handled. Decades earlier, perfectly carved stone spheres of uncertain origin were found scattered across Costa Rica, some weighing several tons and dated to pre-Columbian times. While none of these objects match the technological complexity of the Buga sphere, their existence demonstrates that mysterious spherical artifacts have appeared across different cultures and eras without clear explanations. Perhaps the most unsettling aspect is how the Buga sphere blends qualities of both artifact and machine. It is small enough to hold in your hands, yet engineered with a level of internal organization that no known natural process could replicate. Every test meant to simplify the mystery, whether through chemical analysis, structural scanning, or electromagnetic measurement, has instead revealed new layers of complexity. If this is a product of human craftsmanship, it represents a leap in materials science that has somehow escaped public record. If it is not of human origin, then we are looking at a piece of technology whose purpose remains entirely unknown. Physics on the edge. What the pulse could mean. When scientists began to analyze the second pulse from the Buga sphere, the first surprise was not only that it repeated, but that the intervals within the pattern suggested a level of control that is difficult to explain using known physical processes. The signal was not simply a burst of random static, it showed a rhythm of rising and falling amplitudes that repeated with remarkable precision, as if the sphere were deliberately modulating an internal source of energy. One researcher described it as similar to a musical phrase that plays exactly the same way each time, an analogy that immediately raises an unsettling question. Is this an intentional communication? Or is the object simply revealing a physical property of its design? To understand why this matters, imagine the concept of negative mass, a hypothetical property discussed in advanced physics for decades but never observed directly. In simple terms, negative mass would behave in the opposite way to normal matter. Push a shopping cart with positive mass and it rolls away from you, but if it had negative mass, it would accelerate toward you instead. This counterintuitive motion breaks the everyday rules we experience, but remains mathematically consistent with certain models of space-time. Now consider a sphere capable of emitting pulses that slightly alter its apparent weight during testing, as some preliminary measurements suggest. Even a small reduction in gravitational effect during the emission would hint at a mechanism similar to negative mass, where the object manipulates the relationship between its own mass and the surrounding gravitational field. Such an ability could allow propulsion without conventional thrust, essentially letting an object fall in a direction of its choosing. Another speculative framework involves electrogravitic technology, a concept rooted in the interaction between electromagnetic forces and gravity. In classical physics, these forces are distinct, but some fringe theories propose that under extreme conditions, electromagnetic fields could create localized gravitational effects. The Buga sphere's faint electromagnetic signature, combined with its unexplained pulses, tempts some researchers to wonder whether it is generating a controlled electromagnetic disturbance that temporarily alters its interaction with Earth's gravity. If true, even in a limited form, this would represent a technological breakthrough that current aerospace research has never achieved. Patrick Morsewa's fractal space-time model offers another intriguing possibility. His theoretical work suggests that under certain conditions, matter might contain self-similar networks, like fractals, capable of interacting with the underlying geometry of space-time itself. According to this model, a structure engineered with precise fractal patterns could create localized regions where normal physical constants fluctuate. If the Buga sphere's internal microspheres and filament networks are arranged in a fractal configuration, the repeating pulse could be the measurable output of this interaction, not a message, but the side effect of a system maintaining equilibrium within a distorted space-time lattice. Such a system might even draw ambient energy from the surrounding environment, explaining how the sphere emits signals without any visible power source. But what if the pulse is not a signal at all? One possibility is that it represents propulsion residue, an energy discharge that occurs when the object adjusts its internal state. Just as a rocket engine leaves a trail of exhaust, a device that manipulates gravity or mass might produce detectable pulses when it resets. Another theory proposes that the pulses are internal diagnostics, essentially the sphere running self-check routines to maintain stability, much like a computer performing regular system tests. A third hypothesis is that the pulse is an environmental response similar to biological sonar. Certain animals, such as bats and dolphins, emit sound waves to map their surroundings. If the sphere is a probe or autonomous device, the pulses might allow it to gather data about changes in pressure, electromagnetic fields, or even the presence of living organisms nearby. If any of these ideas prove correct, the implications stretch far beyond curiosity. Consider transportation. A device capable of reducing or redirecting its own mass would make current aerospace technology look primitive. Vehicles could rise vertically without propellers or fuel, glide silently through the atmosphere, or travel long distances without worrying about drag or inertia. Energy generation would also be transformed. A sphere that manipulates gravitational fields or draws power from space-time fluctuations might operate without conventional fuel, opening the door to clean and virtually limitless energy sources. Communication could be revolutionized as well, since a system capable of sending structured pulses through gravitational or space-time channels would bypass the limitations of radio waves and fiber optics, enabling instantaneous signaling across vast distances. Such possibilities also introduce serious risks. If the sphere's pulses are more than harmless signals, they could represent radiation or energy releases that we do not yet understand. An object capable of altering its own mass or gravitational interaction might inadvertently destabilize its surroundings if mishandled. Some scientists quietly worry that the pulse could be a beacon, intentionally or unintentionally broadcasting Earth's location to unknown intelligences. If this is a probe sent by an advanced civilization, answering it might invite contact we are not prepared to manage. The stakes explain why military and government interest has reportedly intensified. Control of a device that manipulates mass or generates fuel, less power, would confer enormous strategic advantages. At the same time, the global scientific community argues that any research must remain transparent and cooperative. A discovery with potential to reshape physics, energy, and transportation should not be locked behind national security barriers. The tension between these positions is already visible in the cautious language of official statements, which emphasize international collaboration while quietly restricting access to the most detailed data. Humanity's response will set a precedent for how we handle future encounters with technologies beyond our current understanding. Should researchers attempt to decode the pulse, risking unintended consequences? Or should they focus only on passive observation? Do we treat the sphere as a scientific specimen, a potential communication device, or a piece of advanced machinery that could be weaponized? The answers are not simple. Proceeding too quickly could be dangerous, but waiting too long could mean missing a transformative opportunity. Perhaps the most haunting question is whether the sphere is aware of our scrutiny. Every new pulse feels like more than a coincidence, as if the object responds to the very act of observation. If that is true, then the Buga sphere is not merely a silent artifact, but a participant in a dialogue we have only just begun to hear. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.